So this is going on page 50. Like I said, it's very simple, but you have to know how to factor. In pre-cal, we'll do polynomial sign charts. We need to know how to use them. We're going to use rational sign charts more, but when you get into calculus, you use both. Daisy's not here today to reassure you that I'm not lying, but promise you I'm not lying, because last week in BC, they started using them again. I was very proud of my former students because Mr. Ackerman said, they remember doing these. I was like, yes. Even if you don't remember how to do it 100%, if you remember that you did it and it can come back to you, it's coming from a different part of your brain, and that's why you learn things a little bit at a time. So, all right, so let's talk about inequalities real quick in polynomials. So, given a polynomial function f of x, a polynomial inequality has the general form of one of these. Basically, instead of an equal sign, it has an inequality sign, which does include the equal with a slash through it, because that means not equal. So if I have the inequality, f of x is greater than 0, that is true when f of x is positive. Because isn't that what greater than 0 means? Yes, it is, okay? But let's talk about what this is really saying and what it means to you when you're looking at stuff. It means that the function is greater than 0. The function is positive, right? F of x represents what? What else could f of x? What else could I write besides f of x? Y, okay? So that means when y is positive. Anytime you talk about the function value being anything, it's the y value. The function is the y because y is a function of x. That's why we use function notation. So, similarly, I should have chosen a different word because I can't say that one. This inequality is true when f of x is negative. So far, nothing groundbreaking, right? But I do want you to think about the function. When the function is positive or negative, we're talking about when y is positive or negative. Okay? So we're given a function. We're given it as an equation. We're given the graph. And it tells us to name all the intervals in which f of x is greater than 0. So that means when is it positive, right? So I can look at the graph. The graph is positive here and here. Okay? And we've already written these types of intervals, but remember, you can get things backwards and confused and you don't want to. We are talking about y. When is y positive? But what we write are intervals of x. The only time, unless you're asked for an interval of y for some reason, that you write intervals of y is when you're talking about range. Okay? So we're writing intervals of x, talking about the intervals of y. So y is positive when x starts way out here, since this is going to keep going like this. So out here at negative infinity, my x value, so I'm going to start at negative infinity, and the graph is positive all the way until I get to negative 3 on the x-axis. Now, we never include our infinities. Do I include the negative 3? What is the function value at negative 3? 0. Is 0 positive? No. Okay? So we have everything above the x-axis is positive, everything below it is negative, and everything on it is 0. So I do not include it. Oh, and I missed one. I missed that part there. Okay. So from negative infinity to negative 3, my function's positive. It starts being positive again here at negative 1. And then until we get to 0. I don't include either one of those either, because again, that's when the function value is 0. And then it starts being positive again at 1, so I union that and go from 1 to infinity. And remember, your union sign does not have a tail on it because it's not a U. It is a symbol that looks like a U. Don't put a tail on it like you're doing a capital U. Okay? Everybody good? All right. So then we want all intervals when f of x is less than 0, so that's negative. So my function is negative here and here. So the function, excuse me, the function begins being negative when x is negative 3. The function remains negative until we get to negative 1, not including either one of those, because then that would be 0, and then starts over at 0 and goes to 1. And notice how this piece fills in this gap, And this piece fills in this gap because it's either positive, negative, or 0, right? Any questions? That's kind of a review because we've already talked about that. Now let's look at what happens with the sign chart. So I'm going to read you these steps, and I put them on here, but I don't think you necessarily have to go back and check step 3 or whatever. I think once you start doing it, you'll, naturally kind of do it all. But so we're going to set the polynomial equal to 0. We know how to do that. But again, you always have to set it equal to 0 first. We have to completely factor. So 2 things there. You have to know how to factor, and you have to know what completely factor means. Some of you that can factor don't completely factor even when you're told to do so. So I'm not sure if that's because you don't think you need to or you don't know what it's asking you. Then we're going to plot the zeros on a number line. We can do that. That's super easy. Then we choose test points in each interval. This is the one where I'll re-explain it when we get there. But we're going to choose test points. We substitute them into the function and determine if it's positive or negative. And we construct a sign chart. And then we shade the sign chart above and below according to the signs. Okay, so 4 and 5 are new. We can tell you we've done 1 through 3 a ton. So let's see what's happening here. So I'm going to set this equal to 0. 0 equals x to the 4th minus 26x squared plus 25. I need to factor it. A is 1, so I can jump to my 2 parentheses. This is going to be x squared and x squared. 2 numbers that multiply to give me 25, combine to give me negative 26, negative 1 and negative 25. So this is factored, but it's not completely factored. And I can find the zeros from here, because, I could, and it wouldn't necessarily be wrong if all I'm asked for is the zeros, but I need to completely factor it. So 0 equals x plus 1 times x minus 1 times x plus 5 times x minus 5. So now that it's completely factored, I'm going to put my zeros, and since I'm going to have to plot them on a number line, I am going to do them least to greatest here. So I get negative 5, negative 1, 1, and 5. Excuse me. So here's completely factored and my zeros. Then I'm going to plot them on the number line. I do not care about, I do care about accuracy. It's got to be, they have to be in order, but they don't have to be spaced out correctly. You kind of want them spaced evenly, even if their numbers aren't spaced evenly, and you'll see why in a second. So I'm going to have a negative 5, negative 1, 1, and 5. So the only part of accuracy I care about there is the order. The spacing, don't worry about it. Okay? It's just not to scale, and it's fine. All right, so then I have my number line, and I'm going to plot my points. So I have 4 points here. It's the ones I just marked out. There's absolutely no need to make every single little hash mark. That'll just add to your confusion, okay? Don't do that kind of stuff unless you need to. It adds more stuff that can confuse you, and then it's also just, you don't need to use that time. Okay, so now we're going to construct our sign chart. Here's what we do. We select a number in each interval. Now, don't forget about the ends, because we're starting out here at negative infinity and going to negative 5. So I need a number that's between negative infinity and negative 5. I'm not going to pick like negative 2,000. That would be more difficult than necessary. I can pick negative 6. Totally fine. So I'm pick negative 6. And then I substitute it in here, but the good news is we're not really going to multiply a bunch of numbers. All we care about are the signs. So when I substitute negative 6 in here, that would be a negative 5. So that's a negative. Put a little negative sign. I substitute negative 6 in here. Negative 6 minus 1 is negative. Negative 6 plus 5 is negative. Negative 6 minus 5 is negative. So whatever the numbers are, when I put them in there, I'm going to have a negative number times a negative number times a negative number times a negative number. So when I multiply 4 negatives together, that becomes positive overall. In Delta Math, it does show you when they do it, they actually put the numbers down, and I think they even multiply the numbers together. Whatever number you get is completely irrelevant and totally not worth the brain cells or the time that it takes. So I'm not real sure why they actually do that, but yeah, that's another thing you probably don't want to follow. Okay, so then I go, so look what happens when I substitute in negative 5. This would be, I'm not going to write it down because we're supposed to be in between, but if I substitute in negative 5, I would get negative, negative, 0. So then does it really matter what these are? The whole thing would be 0, and we already knew that. It's a 0 of the function, right? That's why we have to pick numbers in between. Because I know it's 0 here. Between -5 and 1, I want to know, is my function positive or negative? Because sometimes that's all you care about. You don't care about the actual values. So we'll pick whatever number you want to pick, it's fine. We'll pick -2. So -2 plus 1 is negative. -2 minus 1 is negative. -2 plus 5 is positive. -2 minus 5 is negative. So when I multiply all 4 of those together, I would get a negative number. You see why you kind of want them spaced now so you have room for your little signs? Between -1 and 1, I can pick 0. Anytime I can pick 0, that's great. So put it in here, that'd be positive, and then negative, and then positive, and then negative. So that's positive overall. Between 1 and 5, I can pick 2. So 2 plus 1 is 3, so that's positive. And then 2 minus 1 is positive, and then positive and negative. So that's a negative overall. Don't forget about the ends. So on this side, I'll just pick 6. When I substitute it in here, that's going to give me positive, 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 positive. That's positive overall. So then remember that the number line is like your x-axis. That's why we plotted these points, because there are zeros. So if it's positive, that means the function is above the x-axis. When it's negative, it's below. Positive is above. Negative is below. Positive is above. So this is my sign chart that would tell me, I know that my function is positive between -1 and 1. That also tells me, since I know it was negative and then it's positive and then it's negative, between -1 and 1, I also have a relative maximum. I don't know what it is, but I know that there's one there, and that might be all I need to know when I'm applying what I'm doing. Let's think about what we already knew about these functions. This is a polynomial. This has an even degree, which means the end behavior models a quadratic. So it's either up, up, or down, down. This is positive, so I do know that my end behavior is up, up. And when you look at your sign chart, isn't that what your sign chart is telling you also? Okay. And that's why when you were sketching these in Delta Math, if you were looking at the explanations they gave you, they had sign charts on some of those. We just hadn't done them yet, and you didn't really have to have them to do what we were doing, so it just kind of wasn't necessary yet. But that's what they were getting at there. Okay. Everybody good? Any questions? Okay. Excuse me. So this one's already factored for me. That's great. So when I just set it equal to 0, I can get my zeros out of this. So x is equal to, so my smallest one's going to be -3, then 1, then 5. So I'll come down here, and I have a -3, a 1, and a 5. And I will plot those points. So now I'm going to choose numbers. So I'm going to choose a -4, okay? When I put -4 in here, that factor is negative. When I put -4 in here, that's negative. -4 plus 3 is -1, but we square it, so it becomes positive. So really it doesn't matter what we put into this one, because we're squaring it, it's going to be positive, or it's going to be 0, but we won't be getting 0. If you get 0, you did something wrong. It's going to be positive no matter what. So that means that this one is positive overall. Between -3 and 1, I can pick 0. So that would be negative, negative, and then positive again, which makes it positive overall. So if you were thinking on the first one, oh, well, they just alternate, so why do we have to do more? Because they don't all just alternate. That's why. Between 1 and 5, I can pick 2. 2 minus 5 is negative, and then positive, and then positive. So this is negative overall. 6 is going to be positive, positive, positive. That's positive overall. So then I shade. This is positive. This is positive. This is negative. This is positive. This function, the degree, this is 2, 3, 4. So it's an even degree, and it's positive again. So my end behavior is up, up, just like this shows right here. This doesn't alternate. So tell me what's happening from what you know already. What's happening on your graph here at -3? A bounce, which our real word for that is tangent. Okay. So graphically, when you're sketching, it bounces off the axis, which makes it tangent. So make sure you know both. I think bounce helps you with the visual, but you got to know tangent. And that is what's happening here, because we know that from this, because we already know how to look at polynomials, right? Also, if we think about what is happening here, it's positive, right? It's positive, and then we have to get to the 0. Then it has to be positive again, so it's going to have to come back up, right? And then it's going to have to hit 0, then it's negative, and then it comes back up from here. So you can use... Sorry. Don't worry, I'm not actually sick. I just cannot get rid of this cough or anything. Some days it's worse. So I can use this sign chart, even if I couldn't see any of that. If this is all I had, I'm positive here. I have to get to 0. I bounce up. I have to come... Oh, sorry, I got to do it from the side. I can't see. I'm positive. It bounces up, and then it hits 0. It's negative. It hits 0, and so my polynomial looks something like this. What I don't know from the sign chart is my y-intercept. That's really the only thing I don't know from like when we sketched them, because I didn't know then either how far to go up or down on these, right? We still don't know what the actual relative maximum or minimum is. I just know that I have one, which again might be enough. Okay. What questions you got? We good? Okay, so here's a sign chart, and we're going to sketch it from the sign chart. These numbers are really small. So this one, this is at -6. You can probably read it better on your paper. The board's always horrible. -4, -1, and 1. So since we are sketching this, this is not just a number line, and I'm not going to do a sign chart because they gave me one. So I do need to space them out as evenly as possible. We don't need to get a ruler out. And I do have to make hash marks on the x-axis here. The farthest I'm going out is -6. I like to have at least one more if possible, so we'll see what happens once I start making them. But 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Really don't spend more time than that putting your hash marks on there. Okay, make an honest effort. If I did have my y-intercept, I don't have to make hash marks on my y-axis because I don't have more than one number, but I do have to label what it is. I can't just like put a hash mark and not put a number there. But we don't even know what it is here, and that's fine. So I'm going to put my points on here. I have -6, -4, bless you, -1, and 1. So my end behavior is positive, positive, so it's up, up. So then I know when I start, and I alternate. So this is positive, and then it's negative, and then it's positive, and then it's negative, and then it's positive again. So there's no tangents here, no bounces. And I don't have enough information to know whether or not there would be a point of inflection. There might be. We don't know, so we can only sketch what we can sketch. So I'm just going to start up here knowing that it's all going to alternate. So I'm going to come hit 0, back up, back down. Don't know where my y-intercept is. That's fine. And it looks something like that. And you can always make your points bigger if you hit it. What questions you got? Okay. Then you do number 4. Do I have any tangent pieces here? Yes. It's going to be tangent to the function at -3. I'm sorry, at +3. So I start down here. It's negative, then it's positive, and then it's negative, and then it bounces right there. That's really bad, so let me try again. So it's negative, positive. Something like that. Okay. And I know that I have to have that there because it remains negative, but it goes to 0. So when I come here and it's negative, then I have to go up and I have to hit 0, but then the function's negative again. That means I'm going to have to come back down to be negative. Okay. Any questions at all? We good? Okay. All right, so now let's talk inequalities, which is kind of more where this is all leading. The steps are the same, except for 3, we used opened or closed. We'll talk about that in a minute. And then we have to write it using interval notation. So because this is not a statement of equality, it's a statement of inequality, when I plot these points, are these going to be opened or closed? Closed. Are these going to be open or closed? Open, okay? Basic stuff we should know, right? So I can't really say that I'm setting it equal to 0, even though I think that's what the words say, because it's not a statement of equality. You need 0 on one side, and you have to do it legally. That's what matters. So I've got to move this over. I'm going to move it over legally, which means I have x to the 4th plus 4x cubed. I have x squared. I'm going to subtract a 10x squared over, so that's minus 9x squared minus 36x is greater than or equal to 0. When you are solving inequalities, what operation do you do that requires you to flip that inequality sign? Dividing by a negative or? Not just dividing, multiplying. It's multiplying or dividing by a negative. So don't forget that. If that happens to come up, that doesn't come up right here, but just remember those inequality rules. All right, so now I've factored. I just treat it like it's a statement of equality. So I have a GCF. I'm going to factor out my x. Gives me x cubed plus 4x squared minus 9x minus 36 is greater than or equal to 0. Okay, so then I have to factor that by grouping. So I have x times, can factor out an x squared, leaves me with x plus 4 minus 9 times x plus 4 greater than or equal to 0. Sorry, I know me clearing my throat and coughing is very annoying, but it's even more annoying when you're the one doing it. So, sorry, driving myself crazy too. So I have x times, then x squared minus 9 times x plus 4 is greater than or equal to 0. Hi, yes. I don't know if you can really drive this back here, so you might have to walk them back and forth, but they're all on that table right there. Yeah, all those are on one table. Thank you. All right, so again, this is factored, but it's not fully factored, right? So this is x times x plus 3 times x minus 3 times x plus 4 is greater than or equal to 0. Now it's fully factored. Now I find my zeros. The zeros that satisfy this function are, and I'll put them in order, so I have a negative 4, then a negative 3, then a 0, then a 3. Okay? So fully factored and found my zeros. Which so far, it's exactly the same as what we did on the front, right? Put them on my number line, so I have negative 4, negative 3, 0, and 3. Obviously not to scale, totally fine. Make it easy for yourself to put your negatives on there. All right, and then because this is greater than or equal to, that means I want all of the values that are positive and 0. It's greater than or equal to 0. So we'll do closed circles again. Now we test points just like we did on the front. Don't forget about this guy. He is important. So when on the left of this, if I pick a negative 5, negative 5 substituted into here totally gives me a negative. Negative 5 plus 3 is negative, then negative, then negative. So all of that gives me positive overall. Between negative 4 and negative 3, I don't have the luxury of picking a whole number. because I can't pick negative 4 or 3. I can pick negative 3.5 because I don't have to actually do the math anyway, right? So negative 3.5, this would be negative, this would be negative, this would be negative, and the last one would be positive, which makes that negative overall. All right, you finish up this sign chart. Just finish getting all your negatives and positives in there. Thank you. So I didn't want to talk you through the rest of that because I wanted to make sure you understood how to do it on your own. You understand how to substitute them in. We're all good? Okay, so now I'm going to shade. This is positive, negative, positive, negative, positive, right? Okay, so then when I write my answer to this, it has to satisfy this inequality greater than or equal to 0. That means I'm looking for the places that it's positive and 0. Okay? I mean, you can't be positive and 0 at the same time. So positive or 0, those both work. Okay, so it's positive. It starts being positive out at negative infinity. I never include my infinities. Then I go all the way to negative 4. Think about what's happening here and what we're asked for. Do we include this negative 4? Yes, because I want it's positive when it's between. At negative 4, it is 0, and that's part of it, so I include it. Then I start back over, and I go from negative 3 to 0. Do I include those? Yes, because it's 0 at negative 3 and 0. And then it starts back over at 3, and we go to infinity. We never include infinity, and we do include the 3. What questions do you have? We're all good? All right. Let's do this last one together. So again, I'm going to move this over legally. So this is going to give me 3x to the 4th minus minus 11x cubed minus 4x squared is less than 0. All right, so then I factor out my GCF. X squared times 3x squared minus 11x minus 4 is less than 0. Notice I rewrite the entire thing every time. You have to do that. You can't get sloppy with that. All right, so then I'm going to have to factor by grouping. So two numbers that multiply to give me negative 12, combined to give me negative 11, will give me 3x squared minus 12x plus x minus 4 is less than 0. And I factor, so I get x squared, and factor out a 3x, that leaves me with x minus 4. And factor out a 1, leaves me with x minus 4, less than 0. So x squared times 3x plus 1 times x minus 4 is less than 0. Okay, so that is fully factored. Find my zeros. My smallest one is going to be a negative 1/3, then 0, then 4. So those are the pieces that I need right there. This says less than 0, which means I need to know when it is negative, right? This time it's not negative and 0, it's just negative. So I'm going to put my points on here. I've got a negative 1/3. Got a 0 and 4. Are my circles opened or closed? Opened, because it's just less than. So open circle, open circle, open circle. Okay. It's important here, even though I realized you could just put closed circles and you could decide whether it was greater than or equal to, that sort of thing. But when we get to rationals, our number line is going to could possibly have opened and closed on the same one. So you just want to get used to doing that. Okay, so then let's find our signs here. So something less than negative 1/3. How about negative 1? Okay, so I put negative 1 in here, and then I square it, which makes it positive. Negative 1 times 3, negative 3 plus 1, so that's negative. Negative 1 minus 4 is negative, so that is positive overall. So between negative 1/3 and 0, I don't have the luxury of figuring out I don't have the luxury of using a whole number. So really the easiest thing to do would be just to take like half of this, because that means it'll kind of work nicely with this. So half of this would be negative 1/6. It would be less than that, right? So we'll take negative 1/6, but when we square it, it's positive. We don't really care what the number itself is. Then negative 1/6 times 3 is going to be a negative 3/6, which is negative 1/2 plus 1 is positive. They had to do a tiny bit of math there just to make sure I got my signs right. And then this one would be negative, so this is negative overall. Between 0 and 4, I can pick 1. 1 squared is positive.
Teachers, that 9:30 bell is your reminder to go ahead and take attendance.
Did it ring?
Today. Also,
I didn't
please
hear
ensure
it.
that your students are signed up for
Did y'all hear it?
math time and enriching students.
I just heard something fall.
Thank you. Have a great day, members.
Okay. All right, so we have the 1, we square it, then this is going to be positive, and then this is going to be negative, right? And so that's negative overall. Put in my 5. It's going to be positive, positive, positive. That's positive overall. All right, so then we shade. Positive, negative, negative, positive. Everybody with me? And remember, we wanted less than 0, so we want when it's negative. It starts being negative at negative 1/3, all the way to 0. We do not include either one of them because they are open circles, right? Then we start back over being negative at 0 to 4. Why don't we include 0? When x is 0, what's the y value? 0. And it has to be less than 0, right? Now, on this particular question, if it had been less than or equal to, if these were closed circles and it was less than or equal to, then we could write it as one interval from negative 1/3 to 4, because then that 0 would be included. You wouldn't split it just because it's in 2 sections, okay? What questions you got? We good? All right, then get your Delta Math out, get going.